Hey everyone, I'm Saurabh and I'm a professional data engineer. I have like 4 years of experience. So I have started this series where I will be teaching you guys SQL from scratch. So if you haven't watched the earlier part, you can go to my channel and check that video out. If you have sticked till this moment, so you have covered a major part of the SQL. Now we are getting deep in advanced topics of SQL. So now we are approaching SQL joins. So SQL joins is one of the most important topics of SQL, and it is the most asked in interviews. Not asked, but like it is the most used thing in SQL. So let's see what are SQL joins. As the name suggests, joins are used to combine two different tables together so that we can have like different columns side by side from two tables on the based of one common column. Let me give you an example. So let's say we have two tables. One is student. So it have student ID, student name, and the class of the student. And our next table is enrollment table. So this have enrollment ID, subject ID, and subject. As you can see, the data present in both of these tables. So in student we have student ID, roll number, student name, then in which class he is in, and in enrollment we have the names of the subject and which student have enrolled in like which subject. So if we want to see like Alice has opted for which subject, how we can see that? To do that, we need to join these two tables. Student, we need to join with enrollment on the basis of what? There is one common column in this, which is student ID. So here we can see number one, student ID number one. So Alice has taken maths. Alice has taken science. So we join these two tables based on a common column. So that's how join works. So I have already explained you about joins, but before I proceed further, I want to explain you guys why do we need joins. Why cannot we have all the data in one table? Let's see that. Okay, so let's say we have this table, employee details. So these have all the data in one table: employee ID, name, address, salary, phone number, his investments, his medical insurance, his project, current project, new project. So in this kind of scenario, what if this Rahul person has worked on like 10 more projects or like 4 more projects? So 4 more records will be added for Rahul. Okay, right? So now what if his address changes? So we have to update address on all of these 5 records. And same goes for salary, same goes for phone number, same goes for investment and all of these. So all in all, like it will be chaos in this kind of scenario where all the data is stored together. And one other issue is there that if you see like we are seeing data duplicacy, right? Let's say his only project is changing. So in all of these 4 records, his project will be different, but rest of the details are getting duplicated. So the storage used will be increased in this kind of scenario. So instead of storing data all together, what we do is we store them separately in different entities. And like this, those entities we call them ER diagrams, entity relationship diagram. So what we'll do is like we create one entity employee, one entity department, project, and this. So every entity will hold some sort of data related to that entity. Like employee details will have gender ID, these kind of details. Project will have his project related details. Department will have some salary kind of details. So here I have created these 3 entities. Employee details will have his ID, name, address, phone number. Then these details are for HR, so employee salary, medical insurance, his investments, and these are project related details. So this is a different table. So this is why we create different tables to store data logically, and so that we can we can extract data logically if and when it is required. So this is what RDBMS is, Relationship Database Management System versus DDMS. In RDBMS, we store data in different tables. This joins is a concept of RDBMS. And we will explore more on this further advanced series where I will be teaching you guys about data modeling in data warehouses. There we'll discuss more about this. If we see in this diagram, we have like 6 7 types of joins we have. The most basic join we have is inner joins. As you can see in the diagram, inner join gives us the common data from both of the tables. So for example, in these two tables, like the inner join will give us only 1 and 2, like these two. Only common data is these two. Okay, let me show you with example. So this is the example of inner join. If we run this, you can see these students like Alice and Bob, only these are the common data. The syntax for inner join is select, then which columns we need to select, then from the first table, and then inner join this, then second table. And this is just an ADS, like we can refer to this table with only this letter only. So table 1 inner join, table 2, then on which column you want to join, s dot student id equals to e dot student id. So that's how we are getting this, common data between both of the two tables. So after inner join, we have left join. So as the name suggests, left join, it will give us all the data present in the left table, like table 1. If we can see in our example, okay, so if I run this or left join, like same thing we are doing, only thing we changed is this from inner join to left join. So in left join, we are getting all the data from our students table. So this is our student table. So if you see that we have Alice have taken science, Alice have taken maths, Bob have taken English, but Charlie hasn't taken anything. So we are getting null in it in his subject. And David has also not taken any subject, so we are getting null here. So that's how left join works. Similarly, right join, we will get all the data present in B, like second table. Let's see, right join. This is the first table, this is the second table. So if I run this, we will see that the data we are taking from second table, enrollment table, is subjects. So we can see here that maths has taken by Alice, science has taken by Alice, English is taken by Bob. No one has taken history as their subject. So we are getting null in student ID. Okay. So this is the right join. Then we have full outer join. Full outer join will get data from all the tables. Okay. So in full join, what we do is like we find left join and right join and we do a union of this. What this does is in full join, if we do left join and right join, this common data will come 2 times, right? So but what union does is it will remove those duplicates. So if I run this, let's see. Okay, so here you can see Alice has taken science, Alice has taken math, Bob has taken English, Charlie has taken no subject, David has taken no subject, and history is taken by no student. So we are getting all the data here. That's how full outer join works. Now comes our cross join. As you can see on my screen, cross join is not given here. I don't know why, but cross join is also a type of join. So let's see a good example for it. Let's say this one. Okay, so what cross join does is like it will multiply all records from one table with all records of second table. So it will give us all the permutation and combinations of the records. So let's see how it works. So let's say we have one table hair type, then we have next table hairstyle, straight or curly. If we do a cross join, what it will do is it will generate all the possible combination come out of these two. We can have hair type A with hairstyle straight, A with curly, B with straight, B with curly, C with straight, C with curly. So it will give us all the possible, permutation combinations of the records. Like what is the use of it? It can be used in rare scenarios where you want to multiply your data with all the records. So for example, let's say, okay, let me show you example. Okay, so let's say we have this, data students. Let's say we want one column also, like years. Okay, and we want current year for all of these. So what we can do is, like, we can cross join this with a table containing a year value of current year, let's say 2025. So if we multiply 2025 with all of these records, we'll get, 2025 years. So like this is one scenario where we can use cross join. Like I can think of only this, right? If you know any scenarios where we can use cross join, type in the comments down there. That's how cross join works. Now let's see in our case how it will do students and enrollments. Let's try cross join. Okay, so what this has given us, we have student name and subjects. So what it gave us is like each student has taken each subject. So that's what it has given us. David with math, David with science, David with English, David with history. So that's how cross join works. Okay, so there is one last join left, which is self join. So it is very, specific kind of join. So it won't be used very much, but in some cases it is very helpful. So let's see how we have to use it and where it needs to be used. So as the name suggests, self join is joining to itself. So let's say we have a table A and we want to join to itself, table A joining with itself, it will be the self join. Let's see how self join works. So let's say we have, okay, I will show you. I'm creating a new table employee where we have employee ID, employee name, and manager ID. Okay. So I have created this table. Then we have these values: Alice, Bob, Charlie, and David. You can see that Bob's boss is Alice. Okay. Charlie's boss is Alice. David's boss is Bob. Okay. And Alice is in top of the hierarchy, so he has no one at the top. Alice is CEO, Bob reports to Alice, Charlie reports to Alice, David reports to Bob. So this is how it is. If this is a scenario, like how can you, find whose boss is whose? So in this scenario, we use cell join. Okay. Let's see how we are doing the cell join. The result we want is that we want employee name and manager name here. Like one should be replaced with Alice, Alice, and Bob. That is the result we want. So how can we achieve it? So we already know like whose boss is who, but we just want the names here. So the answer is present in this table only. So that's why like self join will work here. So what we are doing is we are joining employee table with itself. So what we will do is like we will take select star from employee. So first table we are considering this as employee table, and the second table we are considering it as manager. So we'll think of it as that the first table contains employee data and second table contains manager data. So if you want to visualize this, this is how it will look. So both the data are same. We just changed its reference. So this table we are referring as employee, and this one we are referring as manager. So this is the result we want. What we want to do is we want to find manager of these employees. So what we'll do is we have the manager ID and we have the employee ID. So we'll join this manager ID with this employee ID. So first employee is Alice. So Alice have manager ID as null. So there is no manager for Alice. So it will look here and it will find no manager for Alice. We'll get the result as Alice 1. This will be null. Now second, it will go to this row, then it will see that its manager ID is 1. So it will take this and it will join it with Bob. Same goes here, like manager ID 1. This for David, it will do this. So this will how our joined table will look like. Now what we'll do is after that we'll delete this one, we'll delete this one, and if you see correctly, let's delete this uh, left. If we see this, we found the managers of all the employees. So this is how cell join is working. Let me show you. Okay, so first table we took as employee, second we took as manager. So what we wanted to do is like we want to find manager ID, manager name for this. So we picked the manager ID from employee table and we joined it with employee ID of manager table. So we'll take employee name from here, employee ID, EMP name, and next what we want is manager name. So manager name we'll pick from here. Manager dot employee name. Let's see how this is going. And we got the result. Now there is one issue with this. What is the issue? Can you spot it? I'm giving you 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the issue is that as you can see, Alice is missing from this table, but we don't want that. Why is Alice missing? That is because we did inner joins. Okay, so what inner join does is it finds the common data between these two columns. So common data is Bob, Charlie, David, Bob, Charlie, David. Alice is not here, like in managers, Alice is not there, so it will hide Alice. How we can correct this mistake? That can easily be done by using left join. Let's run this now. Now, as you can see that Alice is there and now manager has null. What left join does is it will pick all the records from this side and it will try to match it with all the data from this side. Okay, so whatever the common, like whatever common data it will find, it will populate, and if it doesn't find the any matching data, it will mark it as none. Yeah, okay, that's what our left join did and we found the result. So that's how cell join works. Okay, so we have covered the SQL joins. Now if you see this left join excluding inner join, right join excluding inner join, and full outer join excluding inner join, so we have learned about the join. Can you solve these? How can we find these results? How can we do it? Or do we have the solution? If you are able to think about it, I think your understanding is filled well. But if you are not able to think about the solution, I will tell you. So for this, what we can do is, so earlier we have learned about union. So what union does is, it is like an addition of result of two SQL queries. Like if we, get the result from this left join and we do union with the right join, we will get is full outer join. So it will do the addition of these. Same way there is subtraction also. So for subtraction we use except. So if I do this left join and then except inner join, what I will get is this. And same way, if I do right join except inner join, we will get what? This part. So I cannot show you except because my SQL is not supporting except. Here I can show you. Okay, so instead of if I write except, so it is not supporting except here. You can learn more about it from doing a search on Google. If you still don't understand, type in the comments. I will, make a dedicated video for that. But there is one more way we can do this thing. Let's see how we can do that. Okay, so this was our what left child. Okay, so as you can see, we have student name Alice, Bob, Charlie, David. then subject which they have taken science, maths, English. Okay. So this is our student table. So these are all the students which we have: Alice, Bob, Charlie, and David. And the other table which we have is enrollments. So enrollments, you can see these are the only students which have enrolled in these subjects. So what we want to do is, if you see, we want to do what? Exclude the inner join from the left join. We can see that this is our left join. If we exclude the inner join, what we will get an inner join is common of both the tables. So if you see which records are the result of inner join, if you can spot it, 1, 2, 3, 4, 5. Okay, so these three records are the result of inner join. How we can say that? Because these are the only students who have enrolled in some subject, but Charlie and David, they have not enrolled in any subject. So as you can see here, student who have not enrolled in any subject is what we want to get. We want to exclude these three. So how can we do that? So this is our left join. If we do filter on top of it, what do we will filter on? So whoever who has not taken any subject will be the students who are present here. So what we can do is simply where e dot subject is null. So here you can see that we have created this result. So this is how we can perform this. Same way we can do on right join also. This you tried to do it, and same way we can do on full outer join as well. Okay, so now we are discussing date functions. So date functions are very simple. Current date, or now it will give you a timestamp, subtract two dates or date depth. So since we don't have any date kind of table, so we can remove this, we can remove this. Let's see first what this gives us. If I run this, so here you can see, if we do now, select now, it will give us a timestamp 26 one. If I do current date, it will give us like today's date. Now what we can do is we have date diff, right? So let's say we have this date. Okay, so what we can do is, this is 4th of January 2026. This is 1st of January 2026. So if I run this, it will give me that difference of these two date is 3. So there is 3-day gap between these two dates. And can we enter a timestamp inside here instead of a date? Let's try that also. Same way I am writing 1 here. Let's try it now. Yeah, it is still giving us date difference of 3. If you still have doubts, type in comments. I will try to create another video for this. And yeah, that's all. I will be making the next part of this video, so please like, share and subscribe if you like this video. And if you have doubts, type in comments, and if you think I am with something, you can add that too. Let me know how I can improve and all. Yeah, thumbs up. Thanks guys.